Let's go ahead and introduce a complete related rates problem. Simple one. We'll go through a couple examples, take our time through it. These are the steps, really good steps to go through, pay attention to. So you can draw a picture. Not a bad idea. Write down the known information. So you don't need the picture. If you do enough of these, you get the hang of it. But then you write down the known information, write down what you're looking for, write an equation. And we've kind of practiced that in the whole previous section. But let's put it all together. So the radius of a circle is increasing at a rate of 3 centimeters per second. So let's go ahead and draw a circle. And its radius is increasing. So that just means the radius is actually going out, right? It's increasing. So our circle is getting bigger and bigger. At a certain instant, the radius is 8. So what have we been given so far? We've been given the rate of the radius is 3. And it's increasing, so it's positive 3. So dr dt, change in the radius in respect to time, is positive 3. We're also given at a certain instant that the radius is 8. So what is the rate of change of the area of the circle at that instant? Now, they could ask for the circumference. They could ask for the area with the circle. So the area of the circle formula, we're going to try to find what is dA dt. What's the change in the area? That's what we're looking for, right? We want to establish what we're looking for. So here's what we're given. Here's what we're looking for. Drew the picture. We're going right through this. So our area formula, we're going to develop our model. So area of a circle is pi r squared. Now remember, pi is a constant coefficient here. So we're going to take the derivative of both sides. So dA dt, that's the derivative of a, is going to be 2 pi r to the 1 times, we got to do the derivative of the inside function, which is r. Remember how if we took the derivative of x squared in respect to t, you end up with 2x times dx dt? Well, that's just what we did. We just had a pi in front, so it becomes 2 pi r times the derivative of the inner function, derivative of r, which is dr dt. All right, let's substitute what we do know. So we know that our radius at that moment is 8, and we know that we're increasing at a rate of 3. So dr dt is 3. So you can see this is quite a simple problem. So 24 times 2 is going to be 48 pi. So that means at that very moment that our radius is 8, our area is increasing by 48 pi. Let's go ahead and take a look at another problem. So the radius of a sphere is increasing. And I'm wondering if we should go through this one. This is going to be just like the circle problem. We do have a square problem. So let's go ahead and do the square problem because the other one, radius sphere, it's really, really similar, just a different formula. That formula, it's surface area of a sphere. So surface area of a sphere is 4 pi r squared. So it's just using a different formula, but exactly the same thing. So let's just go through this one. So we have a square. Means both sides are the same. That's really important that when they define a square, we know the difference between a square and a rectangle. So we have a square here, and the side of the square, so we'll call it S, might as well, for side, right? That means the other side's also S. So that side is increasing. I'll write the rate right here, ds dt, and it's increasing, so it's a positive rate. Of 15. Then at a certain instant, our side is actually equal to 22. So what is the area of a square? Well, the area of the square, well, we're going to look for what is the rate of change of the area of the square. It could ask for perimeter. I just need to double check. It does say area. So we're looking for the slope, the instantaneous rate of change of the area at that moment. So we're going to find dA dt. Well, what would A be? Well, the area of a square, in this case, would be S times S, or S squared. So when we take that derivative, we get dA dt equals 2s times ds dt. And then we just plug in our known information. So 2 times 22 times 15 and you guys should know how to calculate that by hand. If you already do, no reason to work hard. You can just use the calculator. And there you go. That's the idea of the assignment. So it's not too bad. This is a great introduction. If you get this down, all that's going to happen is we're going to get a little bit more difficult each time.